Hi. Thanks to Amy and Robin for bringing us all together. So I've never been invited to this conference before, but I have busted into the cocktail party because I have so many friends in the room. So I'm delighted to be here. So first of all, the core study that I'll get to after presenting a couple of other quick studies is with Iris Bonet, my colleague at the Harvard Kennedy School, and Alexandra Van Geen at Erasmus University. Alexandra was a doctoral student at Harvard when we were doing a lot of this work. But the core data that I'll present on reducing gender bias really is rooted in work that I did with Modupe Akinola, but our studies just didn't work over and over and over again. So it came back to life in a somewhat different form. But Modupe is certainly part of the history of this project. So I was invited to speak, which was very nice, and I said yes. And then I got another email saying that all the presentations should be about field data. And I wrote back saying I'd be happy to comply, I just don't have any. So they escalated their commitment and they included me anyhow. What I'm going to do is provide a 20-minute pitch for help on how we can find our field data. So all of us are actually very interested in finding a field site to test the core idea that I'll provide evidence for. So if I couldn't sort of provide field data on gender or reducing discrimination, I thought I'd go even more basic and talk about some other work. And what I'm going to do is, rather than provide a theoretical introduction, I'm going to provide you with some data on the core nugget. Our work is amazingly simple. The quick idea that we have is that people will discriminate a lot less based on demographic characteristics if they're evaluating multiple people at the same time rather than separately. Okay, and so that's the whole thing. And now I'm just going to provide you data to try to support that prediction, and then encourage you to give us great insight about where we can actually intervene with an experiment in the field. Prior to the study that you see up there, I published a paper with George Lowenstein and Sally Blount that has the same idea. This problem is a little bit niftier in terms of presentation. But quickly, we stuffed Kellogg MBA mailboxes with one of three problems. Okay, and this occurred in January. Second-year students of their graduating year, and the hypotheticals that we gave them, one group was, nobody sees money or fare, that's to help you. One group is told that it's January 31st, they have, their only offer is expiring, and they need to make a decision about whether or not to take a job offer, and they're given kind of a positive but not particularly interesting description of the job, and it pays them $85,000, and they've heard that other MBAs have been offered $95,000, and the question is, would you take the job or turn it down and remain on the job market? 53% took the job. Another group was offered $75,000, and they're told everybody's getting, all MBAs are getting $75,000, and marginally more people took 75-75 as opposed to 85-95. Okay, so those are two conditions. And then the third condition, which provides a nugget of the hypothesis that we're going to be working on, is that a third condition had two job offers. All the qualitative stuff was similar in value and pre-tested to make sure that that was true. They had two job offers. One firm was paying them $85,000, but paying other people $95,000. The other job was paying them $75,000 and paying everybody $75,000. And they could take the money job, the fair job, or neither, and all of a sudden, the money job became more attractive. So the quick intuition, which we've replicated many, many times, is that people are much more obsessed about social comparison when they're in one situation rather than comparing two or more. Okay. To make that a little bit more general, what you see in front of you is a depiction of some problems that you've seen before. The one on the left, a trolley's coming down the track, and that person in the middle, that's you. If you do nothing, it's going to go to the right, and it's going to kill, and now pay attention for those of you who know the problem, it's going to kill 3 people, not 5, 3. And you have the option of turning a switch, and instead of killing 3, it will kill 1 on the other track. But you'll have to turn the switch to make that happen. Do you do that or not? Then on the right-hand side, trolley's coming down the track, it will kill 5 people. And this time, if you flip the switch, the floor will fall out underneath the person standing on the bridge. That's a large person who will become a trolley stopper. And it will stop the trolley, and you'll save 5 people, but that person will die an instant and painless death. And you can think about whether you would do that or not. All right. So what my colleagues and I do, and my colleagues are Chiat Say, Neda Barak-Korn, and Fiery Cushman, is that we do this joint versus separate, and we ask people the morality of these decisions. How immoral would it be to switch under the problem on the left? How immoral would it be to switch on the problem in the middle? And then in the joint condition, we ask people to compare the morality of those 2 decisions. And basically, the scales differ for separate versus joint. And quickly, people find dropping the person from the footbridge to be more immoral than divert, even though you're saving more people, because people don't like dropping people onto the trolley track to become a trolley stopper. That's somehow affectively averse. And it's more gruesome, and it bothers more people. But when we ask people which is more immoral, okay, then we get a reversal again. And the quick result here is people are more utilitarian and less deontological under joint than under separate. Okay? So pretty consistent pattern. So the core of there's a 70-30 split in terms of the directionality of the preference in the opposite direction from separate. So what, and then instead of having people evaluate others, what we do is we ask people, would you drop or not? 41% will drop the person. Would you switch? 85% will switch. But when we ask people a question where you can only do one or the other, not both, so you have time to switch in either direction, now all of a sudden people drop people from the footbridge because I'm saving more lives. So the question becomes, how do I save the most lives? And when we force the people who do neither, the reversal becomes all the clearer. Okay, so the quick intuition, again, we have this replicated multiple times in Trolleyland. Some people love Trolleyland, others don't. I love Trolleyland. Is that people are utilitarian under joint in comparison to separate. And what I now want to do is just sort of bring that to the question of, can we use this to reduce discrimination? So thinking of joint decision-making as a nudge toward more ethical behavior. This is a slide that, this is an audience that doesn't need that slide. So, I'll get to what's going on here. So you're all employers rather than employees. Employees have solved puzzles for us. And they either solved math puzzles or they solved word puzzles. And you probably have the stereotype in mind. Men solve math puzzles, women solve word puzzles. And in the sample of employees that we hire, there is no main effect for gender on ability to solve our puzzles. Okay, so no gender effect at all. And we hire a bunch of people as employees who solve puzzles. And if you want to know what puzzles means, it's looking for words in that grid, or it's adding up 5 two-digit numbers. And the question is, how many can you do in a very limited amount of time? And our puzzle solvers get paid based on how many puzzles they solve and they solve it in 2 stages, stage 1 and stage 2. And you can think of these employees after we hired them to do this as basically data that we have in a file. We're really interested in our employers, and our employers are told that the mean number of puzzles solved at each stage is 10, and they're made familiar with the task. And their task as an employer is to hire somebody, and they will be paid based on the performance of their puzzle solver in stage 2. Okay? So they're going to get paid based on the performance of their puzzle solver in stage 2. In the separate condition, what we do is that we offer them a specific person who they know to either be male or female. They know that the person solved either 9 or 10 puzzles in stage 1. And then they're given a bunch of filler information about the person that has no predictive value whatsoever. Okay? So basically, the separate folks are either offered male 10, male 9, female 10, or female 9, one of those 4. And Underjoint, what we do is that we offer people either a male 10 and a female 9, or a female 10 and a male 9. In separate, you can either take the person we offer you, or you can take a random employee from the pool. Underjoint, you can take employee A, employee B, or a random person from the pool, and then you're going to get money based on how many puzzles they solved at stage 2. So when I say 9, 10, that's number of puzzles solved at stage 1. And if you think about any reasonable predictive model, a really good prediction of how many puzzles you're going to solve at stage 2 is how many puzzles you solved at stage 1. Turns out past performance predicts future performance shockingly well, and a key theme of Michael Lewis's Moneyball in baseball. All right, so I think I kind of told, so this is roughly what the screenshot looks like, and here's what it looks like under Joint. They pick the person, and basically they get paid accordingly. And here's the data, and it's a little bit, it's hard for me to point all that well. So I'm going to try to direct your attention. First thing is, don't look at the verbal side, look at the math side. Okay? And basically within each of the 4 boxes, the separate data is above the is in the upper left of the box. Okay? So above the diagonal. And the joint, which I'll get to a few minutes from now, is below the diagonal. So the way to read this is 66% of the people who we offered a male who solved 10 puzzles or a random draw from the distribution took the male who solved 10. Of the people who were offered a male who solved 9, 65% took the male who solved 9. People are pretty happy with a male whether he solved 9 or 10. For females, when people were offered a female who solved 10, 44% took the female who solved 10, and the other 56 are taking a random employee from the distribution, and 53% who were offered the female who solved 9 took her, and the other 47% took a random draw from the distribution. A lot of people want to know, why is a 53 larger than the 44, and the best answer I can give you to that is because we didn't make up the data, we actually collected it. And data doesn't always behave exactly like you want. And that is not statistically significant, but there is a statistically significant difference between propensity to hire the male versus the female. Okay, so you base it on the math task, you get kind of a fairly predictable discrimination effect. And by the way, it's hard to get discrimination effects at Harvard. This is like a really bad place. I'm not claiming that we don't have sexism. I'm claiming that our students are well trained to not appear sexist, at least. But this is a notoriously tough place to get explicit choice gender effects, but we clearly have that in this context, and we'll see it flipped in just a few minutes. All right, so then if you look at the 52 and 6, the 52 and 6 are from the same 100%, because that group was offered a male who solved 10, a female who solved 9, or a random draw of the distribution, and not surprisingly, that group likes the male who solves 10. But the really interesting group, because the 57 and the 3 also come from the same group, the group where we offered a female who solved 10, a male who solved 9, or a random draw from the distribution, now all of a sudden 57% are taking the female who solved 10. So we're talking about a one puzzle difference, but with the data on job relevant criteria in front of them, all of a sudden they use the only job relevant criteria that they have, and discrimination seems to disappear. If you switch to the right-hand side, we see the exact mirror image. So people do discriminate against men to solve their verbal puzzles. 81% take the high-performing female over a random choice. 50% take the low-performing female in comparison to 64 and 35. And obviously, 55% take the high-performing female over the low-performing male. But the interesting group is when we offer people a high-performing male or a low-performing female or a random draw from the distribution, 52% take the high-performing male, and sort of discrimination against men to solve word puzzles disappears in the same kind of direction. What I want to highlight is just kind of the strength of the disappearance of gender discrimination. And certainly, we don't have that on real data, that we need help with that. But I want to highlight that based on the data that we do have, and it's quite consistent with the trolley land problem and the social comparison problem, is that people are more deliberative, cognitive, and less using their intuitive stereotypes in joint than under separate. And the strength seems to be pretty strong. So what are some of the implications? If you're in a positively stereotyped group, you don't want to be compared. You want to be evaluated one at a time. If you're a low performer, you want to be in separate because you might get the benefit of some bias going on. Okay. On the other hand, from an organizational perspective, joint leads to higher performance for the organization and less discrimination. Because what I hope you notice is that in our task, the employers who discriminate are likely to make less money. Not a lot less money, but they're the only ones who are going to suffer as a result of their discriminatory behavior. All right. So this is the end of the advertisement part. So we completely plead guilty to the fact that we don't have any evidence that this works in the field, but we want that evidence. We believe that this is that this has predictive power in the real world. We think that if people quit evaluating people one at a sort of sequentially and move toward more simultaneous processes, people would use more performance-based criteria and use stereotypes less. And we really want a field experiment to demonstrate this. And in many domains, field experiments are becoming kind of the gold standard of causal evidence. And in terms of the adoption of sort of field experiments, one of the striking things that I see is that governments, particularly nudge units, particularly the UK nudge unit, are quickly adopting using actual field experiments. Silicon Valley is quickly adopting the use of field experiments because it's really easy to run controlled trials where you just need to change something on a web page rather than actually change human behavior. But running pure experiments on actual human beings who are doing socially interactive tasks, that seems to be more difficult. We think it's something worthwhile. We think that if a company actually wanted to reduce discrimination, and it was a large organization, running a pilot or a field experiment on a subgroup to see whether or not they could get different outcomes by changing the recruitment procedure, we hope has a lot to offer, and we look forward to eventually having the field data that Amy and Robin first asked me for. Thank you very much. Appreciate it.